Lesson 5.2 continues working with radicals and rational exponents. We'll use unique properties related to these exponents. We'll look at products and quotients, we'll add and subtract, and we'll rationalize denominators. As a quick review, a rational exponent is just anything that has a fraction for your exponent. So if we have a base and m over n, remember the denominator is the root, and then you raise it to the m power. So nothing really new here. On the right-hand side, rewrite each rational exponent as a radical. 16 to the 1/2 power, 16 is our base. We put that inside that root. And to evaluate the 1/2, the 2 is our root, so that means it's a square root. Wow, that really was the word root. I don't know why my pen isn't so useful right now. Now the square root of 16 to the 1st power, we could actually evaluate it. That would just equal 4. In the next example, 3x in parentheses to the 2/3 power, now we have to put 3x on the inside. And 2 would be the power, 3 would be the root. So we would have the cubed root here, and then we have to raise everything to the 2nd power. An alternate way we could write that is if we put the exponent on the inside. And this would be equivalent, wow, that's kind of fun. It's like a highlighter kind of. This will be equivalent to our first one. So we could have the cubed root, but if we take the squared to the 3 and the x, that would be 9x squared. Okay, let's try one more. -9 to the 3/2 power. So now we have a base of -9 on the inside. The 2 means we're taking the square root, but then raising it to the 3rd power. Now what makes this one unique is the fact that you're taking the square root of a negative number. We know that that's not possible, so not a real solution. Just looking at converting forms and simplifying if possible. Up next, we have 5 common properties for rational exponents. These properties should sound familiar to you as they really apply for any exponents. We have product of powers, quotient of powers, power of a power, power of a product, and then that negative exponent rule. When you multiply bases, you're taking a product, and the powers or the exponents combined by addition. So we add the exponents together. When you have rational exponents, sometimes you have to find a common denominator. In this case, we have 4 to the 2/3 times 4 to the -1/3. Notice the base doesn't change in our final answer. We keep it 4. But then we add our exponents together. 2/3 plus -1/3. And that would be 4 to the 1/3 power. That's the simplified product of the powers. Quotient of powers, when you divide bases, you simplify their exponents with subtraction. And now this one doesn't have fractional exponents, and I'm not totally sure why. So we're just going to keep the base of 3 the same, and we take the numerator power minus the denominator power. And that would be 3 squared, which equals 9. Power of a power, if you have an exponent on the inside and then the outside of your parentheses, you multiply them together, kind of like giving them a superpower. If we have 7 cubed and we raise it to the 2/3 power, that would be the same as 7 to the 3/1 times 2/3 power. When you multiply fractions, anything on top and bottom cancel out, leaving us with 7 squared. And 7 squared equals 49. Now if you have a power of a product, that means you have a product on the inside, but it's in parentheses. And then if there's an exponent, notice the exponent goes to both of the bases. So we have 16x to the 1/2 power. That means 16 gets the 1/2 and x gets the 1/2. And then try to simplify if possible. Remember, the square root, or 16 to the 1/2 power, is the same as the square root of 16, and that would equal 4. But x to the 1/2 power means the square root of x. And since we don't know what that equals, that's in its simplified form. Last but not least, anytime you have a negative exponent, remember we talked about this the other day. To make a negative exponent positive, you take the reciprocal of the base. And then that makes your negative exponent positive. That's an arrow right there, kind of. All right, so we have a base of 5 to the negative 1/2 power. To make the negative 1/2 positive, we put 5 in the denominator. 1/5 to the 1/2 power. And that's really all you can do using that property of rational exponents. When asked to simplify to reduced radical form, you want to make sure that your, whoops, hang on, where'd that go? All right, we got to get a color to show up here. We'll go with red. You always want to make sure that your base stays the same in your answer. So the base shouldn't change as you're using these properties. Okay, base stays the same, and then you're just going to apply your properties of exponents. And you always want to simplify as far as you can. It says, how can you rewrite each expression using the properties of exponents? We have 81 to the 5/6 power times 81 to the negative 1/3 power. Now they both have rational exponents, but recognize that the bases are the same. When you multiply bases, that's going to be the product of powers property. We can combine them and condense it to one base if we add the exponents together. This is going to equal 81 to the 5/6 plus, that's a plus, negative 1/3 power. In order to simplify that exponent, we need a common denominator. And a common denominator of 6 and 3 would be 6. This would then become 81 to the 5/6 power plus negative 2/6. So then 5 plus negative 2 would be 5 minus 2, which is 3. And 3/6 reduces to 1/2. 1/2 is the same as the square root of 81, and the square root of 81 is 9. And that's what 81 to the 5/6 times 81 to the negative 1/3 would simplify to. In the next example, we have bases that are variables. And we have lots of exponents. We have a fraction. Oh, lots going on here. If we take a look at our properties of exponents, I know that we can combine the x's on the inside by using the quotient of powers property. Technically, x in the numerator is x to the first. But if we have x to the 1/2 in the denominator, we can combine these to just one base using subtraction. And that would be x to the 1 minus 1/2 times y squared, all to the 2/3 power. And this should be pretty manageable to simplify. 1 minus 1/2 is just 1/2, making that x to the 1/2 times y squared. Recognizing that they both have that 2/3 exponent, now this applies the power of a product. I'm going to distribute it to both exponents and multiply them. That means we're going to have x to the 1/2 times 2/3 times y squared times 2/3. So let's see what we have here. I am not doing this right, am I? I just recognized. How many of you caught that this is a 3 and not a 2? I'm sure most of you did. You're good at this. All right. That'll change things significantly in our answer. So I'm glad I caught that now, and we can simplify that correctly. All right, back to business. To simplify the x's, if we have 1/2 times 2/3, the 2's cancel out, leaving us with x to the 1/3. And then get this, with the y's, now that it's 3 times 2/3, the 3's cancel out, and that gives us y squared. Sometimes Pearson will let you leave it in this rational exponent form, but sometimes with rational exponents, they'll want you to convert it back to radical form. which means x to the 1/3 would be the same as the cubed root of x, and then times y squared. That's an alternative answer for this simplified expression. We're going to end the video lesson and things are going to start to get interesting. Have your power chart with you for this part of the lesson. We're going to need that not only for this example, but for the problems on the back. So your power chart is going to be super useful in the next few examples. When you have radicals, the product and quotient property are very similar to what they were for rational exponents. The product property for radicals means you can take multiple parts and split them up. And we've actually already done that. And you can take that rational exponent and distribute it in. So this should kind of look familiar. A quotient property means you have a fraction inside the radical, and that can have the root and the power on the top and the bottom. All right, so what does this do to help us? It says, for example, A, what is the 5th root of 16 times the 5th root of 8 in reduced radical form? You wouldn't want to use a calculator here because that will give you decimal approximations. Grab your power charts and let's see what we can do. If we have the 5th root of 16 times the 5th root of 8, that allows us to multiply the insides together if the root matches. And that would give us the 5th root of 16 times 8, which is 128. Now, if you look at your power chart, 128 isn't on that list. But look at all the numbers in that power chart. There's a number that will go into 128 that's in the 5th powers column. Well, 1 to the 5th doesn't go into 128. Well, I mean, it would, but it's just 1. 2 to the 5th is 32. And if you take 128 divided by 32, you get 4. So we can actually break this down into the 5th root of 32 times the 5th root of 4. It's a product because 32 times 4 would equal 128. Now the 5th root of 32 is a perfect 5th power. That equals 2. But 4, if you look on that 5th powers, nothing goes into 4 that's in that list. That means that's kind of the part that's left over. Believe it or not, that is the simplified radical of the 5th root of 128. It's 2 times the 5th root of 4. And I think that's a good stopping point for us for this video. We'll finish example B and the rest of the notes tomorrow in class.